All right, mathematicians, I want you to complete the anticipation box. So, just using your instincts, what you think might be true, go ahead and complete these congruence statements. So, pause the video and do that. All right, so hopefully you've had a chance to complete the anticipation box. Angle QTS is going to be congruent to, well, angle QTS is congruent to angle RST. Now, why is that? Um, one way you might be able to approach it, if you think about isosceles triangles, if two sides are congruent, then the angles across from them are congruent, so that's all the stuff in red. Well, if we add a segment inside of that red triangle that is parallel to the bottom side of that triangle, and we do it in such a way that the non-base sides of the trapezoid are congruent, well, it stands to reason that those base angles in the trapezoid will still be congruent. So that's kind of where the best way I can explain that happens. All right. Triangle QTS is going to be congruent to triangle. Well, using the reflexive property, we can say that TS is congruent to itself. And now if we look at the markings, we have a side angle side with RST. And the reason for that is side angle side. All right, if those two triangles are congruent, then that means segment QS is going to be congruent to segment RT. So QS is first and last in the congruent statement. RT is first and last in the congruent statement. So those two segments are congruent by CP/CTC. Corresponding parts of congruent triangles are congruent. All right, angle QRS. Well, now we're talking about like the top. We could still call that a base angle. So that angle is going to be congruent to angle RQT. By the same reason as we talked about before, all right, if those two angles are congruent and you use the reflexive property for QR, then we can say that triangle QRS that triangle would have to be congruent to triangle RQT. And that's side angle side again. All right, and then angle RQT, or sorry, RQS, excuse me, RQS. So that's second, first, third would be congruent to second, first, third, QRT. And looking at the diagram, that does make sense. And that's by CP/CTC. Corresponding parts of congruent triangles are congruent. All right, so we said that the diagonals of this isosceles trapezoid are congruent. We said that right here. So if those are congruent, then it means their measures are equal. And so if we have an expression like 6c minus 5 as one of the diagonal measures and the other one as 4c plus 3, we can set them equal to each other. All right, let's get the variables together on one side. So let's subtract 4c from each side. We get 2c minus 5 equals 8, or sorry, 3. And then we'll solve this two-step equation by adding 5. There's the 8. And so 2c equals 8 divided by 2. And so c is 4. Now our goal here is to find QS. So let's plug this 4 back in. So into this expression for QS, let's replace c with 4. Order of operations tells us to multiply before we subtract. So 6 times 4 is 24, minus 5 is 19. So QS is 19. All right, angle TQR is 105. Well, if that angle is 105, then this angle QRS is also 105. That's one of the two that we want to find here. And then we've got parallel lines cut by transversal. Those arrows mean parallel lines. And so this angle down here, QTS, is going to be the supplement of 105 because same side interior angles are supplementary for parallel lines. So let's do 180 minus 105, and we get 75 for the measure of angle QTS. All right, so we found those two missing angle measures that we're looking for. All right, segment XY is in the middle of this trapezoid. Now this trapezoid is any old trapezoid, not necessarily an isosceles trapezoid, but it goes from midpoint to midpoint. And so this segment in the middle is what we're going to call the mid-segment of the trapezoid. If you think about putting the words middle and segment together and making a new word, you'd probably call it mid-segment as well. All right, we're going to work problems 3 through 5 independently, meaning if I write in the diagram, I'll erase it for the next one. So on number 3, we have one base is 8, the other base is 10, so the average of the bases is that mid-segment. So xy will be 8 plus 10 divided by 2. 8 plus 10 is 18. 18 divided by 2 gives us 9 for that mid-segment's length. So that should be no surprise that 9 is right there in the middle between 8 and 10. So if you remember doing things like midpoint on a line, hopefully that would connect with these type of calculations. All right, so number 3 we get 9 for xy. Number 4, MA is 11. So notice the values changed. So that's what I mean by working these independently. All right, XY is 13. And then we want to find KR. So think about how far apart 11 and 13 are. 2 apart. So we can just add 2 and get 15 for KR. That mid-segment is the middle between the bases. And so if you think about how far one base is to another, you can use that same distance again to go from the midpoint to the other base. All right. You should have, I think, 28 is what we'll go with. Yeah, 28 for XY on number 5. So I'll erase the stuff from the diagram. This time we have 28 for XY. We're not given a distance for MA or KR, but we are told KR is 4/3 times MA. So let's try using the formula here, just the average of the bases. So the mid-segment, 28, is the average of the bases. So MA plus 4/3 MA is an expression for the bottom base. All over 2, because we're averaging the two bases. Now if I get a common denominator here, 1 MA is the same as 3/3 MA, and now I can add those together. So I have 28 equal to 7/3 MA. MA is representing the distance from M to A, and so that's my unknown here. You might maybe multiply both sides by 2 to get rid of that division by 2. And so now we have 56 equal to 7/3 MA. To get rid of multiplying by 7/3, we can divide by 7/3, but dividing by a fraction is the same as multiplying by the reciprocal. So I would probably approach it, especially if I'm working without a calculator, as multiplying by 3/7. I'm noticing that 56 and 7 have a common factor of 7, so if you cancel those out, you get 8 times 3, 24. Of course, you can do this with a calculator, and so MA is 24. Now let's put this back in and let's make sure it makes sense. Now 24 times 4/3 will give us the distance from K to R. In similar way as the last one, I would probably cancel a factor of 3, and so 4 times 8 gives us 32 for that other base. And this does make sense. We would add 4 to the small base to get to the mid-segment, and then add 4 more to get to the other base. So we found the distance from M to A as 24, and the distance from K to R as 28. All right, so hopefully this has given you some ideas of what's going on with mid-segments in a trapezoid.